Hello everyone and welcome to the Modern Java course. Last time around we talked about Lombok properties, setters, and creation capabilities. This time we'll delve into some of the more creative and unexpected capabilities of this tool. If you aren't deeply familiar with Lombok, be prepared for some surprises. Before I proceed, as usual, the code for this and the other videos in the series is available in my GitHub page, so check out this project, start, and follow me on GitHub. Java 10 introduced the var keyword. With Lombok, you can use it even with Java 8, which is pretty cool. Var can implicitly fill in the place of a declaration. This is the exact same thing as the keyword. Val is the same as final var. It saves us some typing and is a nice feature, but it's not the best feature I'll discuss today. NonNull is simple feature. It adds an if statement that lets us check if an object is null. Here we can see the annotation in two separate places, on a field and on a method parameter. Notice that the field itself is null, since it isn't assigned. That is okay. As you can see, the annotation just translates to an if statement. If the argument is null, it will throw an exception. The same is true for the field. Methods generated to support the field, such as setters, due to the data annotation, will have that check at the top. This works out nicely with the field being null initially, since we don't set it here. But if we invoke setObj with null, this will fail. Whenever people talk about the stuff they don't like in Java, the checked exceptions come up. I have to admit that I love checked exceptions, but I accept that I'm not in the majority here. A lot of people would love to disable them, and for some extreme cases, they do have a point. The thing a lot of people don't get about checked exceptions is that they aren't a part of the JVM itself. They're a feature of the Java language, but the virtual machine doesn't have that restriction. Unfortunately, sometimes these exceptions are redundant. This is an example of such a case. When we construct a string with bytes and an encoding, it throws a checked exception. But UTF-8 is required in Java, and in recent versions, it's even the default. This will never throw that exception. Adding a catch or declaring a throws makes no sense in this particular case. There are other cases, such as having to write this code within a lambda or a runnable. I won't be able to declare an exception. SneakyThrows disables the checked exception behavior and lets a method throw a checked exception. Passing it without an argument lets us throw any exception, but it's obviously better to qualify the exceptions, as I did here, to prevent additional code in the future from inadvertently invoking a checked exception call that we actually do need to handle. This case is great for SneakyThrows since it will never happen. But word of warning, don't overdo it. This code seems to be fine, but it won't compile. Care to guess why? The reason is that as the Java compiler will look at it, the method doesn't throw an unsupported encoding exception, so it won't let us catch it. We would be able to catch the exception, but we will need to use exception or throwable in the catch statement. Not a deal breaker, but it does make the code less fluid. Moving on, one of the annoying pieces of boilerplate we need to write is this. This is the dual logger code, but this applies to every logger you might have. We can remove all of that hassle by adding a log annotation to the class. It will declare the logger that we define in the configuration, which is remarkably flexible. As we saw before, the log annotation annotates the standard dual logging code. Commons log uses the standard Apache Commons logging API. Log4j targets log4j1 logs, and there's a specific version for log4j2. Finally, SLF4j and the xlogger have their own tags too. But what if you're doing something else entirely? We can define a custom log and write the log in the configuration file that we discussed in the previous video. There we can write any arbitrary logger code we want and it will be generated for us. If you write threading code with Synchronized in Java, you probably heard that this is a bad practice. We shouldn't synchronize on this object since that exposes our internal threading behavior and might cause a problem. This is a better way. We don't expose the implementation detail, but it's a bit verbose. We declare a variable and then synchronize on it. We can instead use this annotation, which effectively is the same as declaring a lock and synchronizing on that. Java 8 introduced try with resources, which made the cleanup annotation less useful than it used to be. It can seamlessly close an object for us by invoking the close method within the try catch block. But since most of those are already auto-closable, this is redundant. But unlike try with resources, cleanup just invokes a cleanup method by default. This is closed, but you can give it any name you want, such as dispose, unlock, etc. That means that we can use this annotation to clean up all the objects that aren't auto-closable but need some tidying up. That's useful. In the next video, we'll discuss an even more ambitious project than Lombok. Stay tuned. If you have any questions, please use the comment section. Thank you.